The third session is another output of the initiative that is downstream control, transitioning from intermittent water supply to 24/7 under severe demand shortage conditions. And we'll have two presenters, Tamer Al-Asad and Pampos Kyriampos. Please. We start with Tamer. Tamer is a program development management and water management expert with the extensive experience working in the management and governance in the field of water, sanitation, and energy infrastructure. More than 15 years experience working for donors, private sector, and public sector. Currently, he is working as water sector management governance advisor in the initiative and leading the governance component of this project. He is a Herbert Humphrey Fellow in Urban and Regional Planning from Massachusetts Institute of Technology. Pampos, the CV and the bio itself is good enough to know the experience of Pampos. Pampos is a chartered civil engineer, chartered environmental and fellow of the Chartered Institute for Water and Environment Management. Experience in water-related fields spans over 40 years and has worked in several projects in Europe, Africa, Asia, and Middle East. Very wide experience in urban water distribution network management, including intermittent water supply, non-revenue water, water losses management. From 1995 to 2012, he was heading the technical service of the Water Board of Limassol, Public Water Utility in Cyprus, responsible for technical and managerial matters, including planning, operation, and maintenance of the water supply and sanitation systems. Since 2012, he is the non-revenue water and water utilities governance consultant and served internationally as senior consultant assignments with water utilities, fellow in the International Water Association, former chair of the IWA Water Losses Specialist Group, currently chair of the IWA Intermittent Water Supply Specialist Group, and the current president of the Cyprus Water Association. Both of you are most welcome. Tamer, again 20 minutes, please.
Yes.
For both, if possible.
Just update the presentation. Then I need to update the slide. Good morning, everybody. I also want to say that our team also include Engineer Mohammed Al-Shafi'i. He is also a major contributor working on this, but to minimize the number of presenters, we will present both of us. The idea of the presentations come out after the non-revenue reduction master plan. We developed also with the help of Pampos and Mohammed, where we will explain the master plan in the next session. But it's important to understand through this master plan, we try to introduce a phased approach on how to manage non-revenue issue in Jordan. As part of the master plan development, the idea of implementing a pilot to demonstrate how the master plan can be implemented come up. And later on, when we look at the management of non-revenue water, a key condition required to have a sustainable management of non-revenue water is to have enough water for continuous supply. Now, continuous supply is a big issue in Jordan. We have always shortage in our resources, difficulties to maintain the supply availability during seasonal effects. For example, the last storm happened in Amman. It cut the water from major resources like Zay and other. So there is always interruption in the water supply. Having this condition making it very difficult to maintain a continuous supply, that is essential to have a sustainable non-revenue management. So the idea come up with this solution that we call it downstream control. to simulate the 24-hour supply. So that's the introduction why we come up with this pilot that we are now designing and going to implement very soon. So that the shortage, the need to have more resources. What's happening here? So because of the need to have more resources, we come up with a count control supply that can be used to simulate the 24-hour. And we want to assess the feasibility of this pilot from all aspects, technical, financials, and social. So just to give how this is happening, what's the difference between continuous water supply and intermittent water supply, which is the case in most Jordan utility except Aqaba, which has a continuous supply. Now, under intermittent water supply, continuous supply, we will have a better water losses control. We have enough supply and equity distribution to the water to end users. And of course, the quality will be maintained better because there is no suctions, no pollution can enter to the network. And of course, asset duration and maintaining asset will be easier. The asset will not have stress times and pressurized time. On the other hand, the intermittent water supply has a big impact on the system. It becomes out of control, high pressures levels there, and of course the possibility of hazards and pollutions increase. The duration of the networks become more quicker, and it's become on the customer also. They have to have additional storage, which means additional cost, and maybe pumping and so on. So that's all implication of the intermittent supply. So we thought under Jordan conditions, always said it's difficult to have the continuous supply. So how we can make a shift or a change in thinking? That's where the challenge we have with limited supply. We don't have enough water to do all the leak detection or revenue measures on the system and to fulfill the customer demand. So the idea is to have to get back to intermittent water supply. It's become like a must in Jordan because we don't have water. So that's where the philosophy comes behind the idea. We need to get with the downstream control. So what was happening under the different conditions now? Currently under intermittent water supply, I said that we keep pushing the waters, filling and emptying the network. The pressure varies always dynamic and varies largely. Usually you need high pressure to meet the demands, so the network is always under different high pressure levels, uncontrolled, because you keep pushing the water. It's become difficult also to see the isolation of the network. A lot of cross connections will happen, and the system become out of control. Now, what we try to say under downstream control, which we explain later, we try to simulate a continuous supply where the water is all the time in the system under pressure, controlled pressure, and usually we try to have minimal pressure, so leakage will be less, and that will lead to more efficient network, and then we'll have the system under control. That's on the network side. With the customer side, under intermittent water supply, usually not efficient supply will be or delivered to customers, so there is no equity in supplying water. Of course, we said poor quality will happen to the system because of the leakage or because of the suction happening in the network, and of course additional storage need by the customer, and that's mean cost on them. Additionally, because not meeting the supply or the demand needs, that means losses in revenue. But under the downstream control that we will explain later, we'll have more control supply. We can control how much water we will deliver to customers. The idea is to keep the network full of water all the time. That will reduce or eliminate the problems of water equality with suction problem, and allow you to detect all interconnections. and at the end, delivering water increase revenues. So what is the idea of intermittent supply? I will explain the first idea and then come to this. Is we try to put at the end user, which is the house connection. The house connections is before the meters, to put a shut-off valve that we can control. And we can close as the rational supply we want, usually like 24 hours, 48 hours. After finishing, we close it, but we keep the water in the network. Of course, later on, we try to reduce the pressure through pressure-reducing valves. And in these situations, we will stimulate the 24-hour with less pressure in the system and delivering the water on the rational supply. And the benefit of that will be explained later by Pampus. So with having this, we can apply all the non-revenue measures on the network through even leak detections, better isolations, if there is problems, illegals, and etc. So to explain the concept, how it's happening under the current, I would need to explain here. Under the intermittent water supply, assume an area which is colored in orange and blue. We have like, assume in a week, we have 50% of the time we have a supply and 50% of the time without supply. So we will need, and we are assuming here that the demand is met. So the blue color is the consumption delivered to the people. So we supply for 50% of the time. The quantity will be the total amount here, which is 32, for example, cubic meter or unit of water, which is both the blue and the orange. The orange will be the leakage because we supply, we meet the demand, and the remaining under intermittent supply will be lots. Now, but for the remaining of the week, which is the 50% of the time, there will be no supply in the network. Now, if we shift it to continuous supply, again with the assumption that demand is met, we still have the same quantity, which is the blue, and we will have usually, because you increase the supply durations, the leakage will be double or increase, and because we say 50% more time, the leakage will be doubled, which is the gray, which is the color in orange, and the orange in hashtag. Now, part of that we can recover. Potentially, you can maybe recover another 50% of it and maybe more. So we still having, after adding putting the non-revenue measures, we still recover part of the leakage, and we could supply the same quantity before and after. Now, this is the easy part. I will not maybe go to this difficult part, but the idea of the difficult part that under conditions that we supply 50% of the time, but the demand still not met. We need more time to supply. That's where we'll have part of the demand not met. But if you want to switch to 24-hour to meet the demand, the case that here the 32 unit water is delivered, but still there is another 8 has to be delivered. So when you switch to 24-hour, we will add another 8. That means you have 40 cubic water unit delivered. But again, the leakage or the losses, it was here at 16. It also doubled because of the duration is extended. Then you can recover part of it. But this is just an assumption for a case. There will be many cases, could be different approaches. Now the idea is how the downstream control work, and how we will apply all the non-revenue measures on downstream control will explain in the following slides by my colleague, Pampus.
Good morning, everyone. Thank you, Mr. Chair, for the introduction. Thank you all for being here. First of all, I would like to thank WMI for giving us this opportunity to try this innovative, in my opinion, approach. And thanks to our colleague Mohammed Shafi, who is also a great contributor to this idea. Now, why downstream control? Personally, I am a strong advocate of transitioning to 24/7 from intermittent water supply. But in being of the region, of the Middle East region, and traveled to a number of countries with intermittent water supply, I always get, the answer that, well, it cannot be done. We don't have enough water. So there must be another way of actually doing away with the detrimental effects of intermittent water supply and still supplying the customers with the same volume of water that we do supply under intermittent water supply. So we thought of this idea of downstream control, and in the next few months, we are going to try in a couple of pilot areas in Jordan this idea. So hopefully, we'll have some results, to show to you of this idea that we're presenting now. Downstream control allows water rationing. Yes, as Tamer explained, we control at the customer level. So there has to be a mechanism there, and we'll talk about it later on, that we control at the downstream level, at the exit point. We have many exit points. So you'll be wondering, well, how can we do this? And we'll give you some detail as to how we're thinking of actually controlling at each customer the water that we give. We can do it either by volume or by time. Now, this is a choice that we have to make along the way. But the idea is to maintain the system full of water. So we don't empty and refill, and I'm not going to go through with the detrimental effects that we have emptying and refilling. Tamer already covered those. So control at the customer level, either using time, so many hours, or using quantity, so many cubic meters or liters per customer. Now, if we do that, what kind of benefits do we have? What can we do as a utility in order to improve the situation? So we have control, bear this in mind. So we have given our customers the volume of water that supposedly they were getting under intermittent water supply. But we will be giving it in a more efficient way. We could actually control the volume that we give to each customer so that there is some kind of equity. Because what we are facing now is that customers at low elevations, they get more water. Customers at high elevations, they may get water. I did come across cases, where customers do install suction pumps. So as soon as the water comes, let me get the water first. So we will do away with these many problems in the network. So the customer side is taken care of. What do we do with the network? This is the beauty of this particular process of downstream control, that we can do a number of things that we're not able to do under intermittent water supply. And one of those things is to manage pressure. As you can see on this particular slide, on the right-hand side, I don't think the pointer is showing, but on the right-hand side, you will see the pressure, minimum 0, maximum 2 bars. The valves are black at the customer level and they are closed. So once we don't supply water to the customer, what can we do? We can reduce the pressure in the network. Not empty that part of the network, but reduce it. So the only pressure in the network is the static pressure given by the elevation in that particular area. But at the very, very high point, we just maintain 0. So we maintain pressure at 0 level. In the rest, the other areas, we can continue and we can control pressure. We can actually do pressure management in supplying the water to our customers. So pressure management is possible under this condition. What next? We meter the water going in because we have continuous supply. So we can have a nice graph. And we'll be able to analyze the minimum night flow. And again, we can see here again on the right-hand side, flow rate, when the valves are closed, you can see the valves all closed, being of black color. It's leakage plus unauthorized consumption, UAC. So the water that goes through when the valves in that particular area, customer valves, are closed, it's equal to leakage plus whatever unauthorized consumption we have. If we don't have unauthorized consumption, that means the minimum night flow equals to leakage. And this is information that we get additionally using downstream control that we don't have when it's under intermittent conditions, because we don't have this particular flow pattern. What can we do with this? We can do active leakage control, acoustic leak detection. In the section of the network that is closed and we have leaks, we can do the acoustic leak detection using standard methods of leak detection. And therefore, it becomes easier to find leaks because the network is under pressure. We are not supplying to the customers, so we have no noise given by the water going through the service connections to the customers. So mainly the noise will come, from the existing leaks. So active leakage control, it's actually possible under this condition. And of course, we can use a very traditional method that we used to use, at least at my early days, in water management systems, of step testing. Step testing is a great way of actually finding out where to start your leakage activities. So you can see from this graph that we have 4 steps, S1 to S4. And as we are reducing the water going, as we are rather closing each step, we are reducing the water going into this area. Now, what is the beauty of these things? The beauty of these things, we can do it very easily because all the customer valves are closed, so we don't have actually consumption. So any water that is lost, it's either leakage or unauthorized consumption. So we can see and we can prioritize in this particular example that we put, step 2 and step 3 are the ones that we should be looking for with priority step number 1. So we can go with step testing and actually find out the leaks in the network that we cannot find under intermittent water supply. Now, I've just highlighted very briefly the benefits of having downstream control without actually doing anything out of the ordinary. All these things, we are doing them when we have continuous supply, or some of them, we may be doing them under intermittent water supply. But how could this be possible? Well, we need a gadget. We need this downstream control valve, and you can see a typical picture of this. Where do we install this? Just before the customer meter. It could be an integral part of the meter, but we'll come to that. Now, this is a solution that it can work either locally, it's an automatic valve, or we can, if we want, at the end of the day, to link it to the meter so that we can have either time or volume control. Now, this technology is available. However, it does not have wide use and is still expensive to some extent. So we will need to work on this and try and convince manufacturer that this is something that will have a wide commercial application, so that there will be more manufacturers coming in. Although, as you can see from this particular slide, there are a number of manufacturers which actually produce this kind of technology. So the knowledge in this particular technology is there, is available. We need to commercialize it. And of course, you may have seen it, and I've seen it in some cases, being applicable in prepaid meters, for instance. I know that in some parts of the world, in some countries, they're pushing with this prepaid meter, which actually does very similar thing. It links an automatic valve to the meter. Now, challenges. We do have challenges. It's not easy. And hopefully, through the pilot projects, we will be able, to have the data and information available to actually convince people. First, the utilities. We need to overcome, this resistance from the utilities for anything new, anything innovative. We don't like to shift out of our everyday work. So we need to overcome this reluctance. We need to convince of the many advantages. And hopefully this presentation has done this to some extent, and the pilot projects will give you more evidence. And of course, we need also to convince the customers to cooperate with us. So with this, I like to conclude this presentation by saying that technology is available. We need to push for the price to go down, and of course, we need funding in order to be able to convince that this is a way forward. Thank you very much.
Thank you, Pampos. Thank you, Damer. We'll have 5 minutes for questions, if there's any. Microphone.
مرحبا. Thank you so much for your presentation. بدي أسأل على التكنولوجيز إنه why should we search, why should we pay and bring funding for for the technologies? Why can't we actually enhance our capacities here in Jordan, and we have developers that we work with them and they can instead of using the funding for buying the technologies, that we can train our resources here in Jordan.
We have all questions. Yes, sir.
Thank you. Actually, I'm very happy and proud that WMI take the initiative for bringing this technology to Jordan. One day in 1985 or 86, I was director of operation of water supply and sewer system. And there was 2 schools in Jordan that time. One of the schools that continuous supply will save water, will not leak the water. The other school is different. I remember my wife and me was living in Third Circle in Amman. And in that time was intermittent supply. My wife was putting the water, storing it in the baño. And we bought a special tank and put in veranda to store the water. When the rotation came to another day or after 3 days to our house, all the old water was thrown to the sewer system. Exactly, that was practically my house. So I am very proud that WMI is bringing this technology to Jordan. And I am sure that we will save water and you will save money and you will save diseases. We will prevent diseases to Jordan. And hope we will be successful, but I am afraid from reluctant people who again don't like changes. You will have really big challenges to convince the people who will say, no, we will waste the water, no, we don't have the water. So this is your challenge. I hope you will be successful in that. Thank you very much.
Thank you, Brother Mark. Thank you. Okay, yes, please. Okay. Thank you, sir.
Again, thank you very much for a super interesting presentation. The question I have is if you see, in an ideal world, the downstream control as an interim solution to fix and identify the leaks in a system so that it's manageable to provide continuous service, or if you see it as a permanent solution that would be in the system for continue or in the future.
Masri?
I would like to ask 2 quick questions about the roof tanks. This will be also dealing with the roof tanks. We know that the roof tanks is like 10% or 15% causing these losses. Second one is about energy saving. Does this make energy saving, or we will pay more because, you know, it's a pressure. Whenever you add something and you get it without having water, this will be causing more energy consumption.
Thank you. Tamer, Pampus, please.
Right. We'll respond, the same order as the questions were asked. The question about the technology and training taking place in Jordan. The idea so far, and you will see this in the next session with the NRW master plan, is that we don't bring something and we adapt to it, but we rather take what we have and we adapt solutions to our particular situation. This is how we achieve sustainability. So if from outside into Jordan, this, in our opinion, should be adapted to the local conditions. Otherwise, we don't have sustainability. Now, these particular valves that we showed in one of the slides were developed abroad, not particularly for this downstream control idea, but for other uses. We're going to adapt them to our situation in order to benefit from it. So yes, the answer is yes. The local conditions will be integrated into this in order to have sustainability. Because what we are lacking in our water industry is sustainability, to be able to deliver the same level of service and improve that day after day. So yes, we will do that. The two schools, absolutely agree with you. I lived through that as well. Although we grew up and and my family were saving also water in packets, we do have this tendency to get fresh water when the water comes. So intermittency for sure has a wasteful element. Reluctance of people, yes, we are facing that. It's just, we need to overcome this initial thing. And this initial reluctance of people. And I'm coming to your question with regard to whether it's an interim solution. It will be for the people who are reluctant. We need to give them small bites at a time and get them to understand that there are other ways of doing things. So I think the downstream control, in my opinion, in many cases, it's not necessary, because if we control the system, we minimize leakage, we have sufficient water. And the downstream control will not be necessary. It would be necessary in cases where we have water shortage, where we don't really have sufficient water and we need to actually ration that water. But at least with this solution, we are rationing based on the needs of the people. So there will be some equity in supply, and we are still not deteriorating our system. We're still keeping our system under control. Now, the roof tanks and energy saving. Basically, I think your question refers to the customer side with regard to the roof tanks. Ultimately, if we achieve 24/7 continuous supply, and we, as a utility, we instill confidence in the users, in the customers, then they can do away with tanks. But in my own country, after many, many years of continuous supply, still the customers, they don't feel confident enough to do away with the tanks. They say, you never know when this utility is going to cut off the water, let me keep the tank. Even in new houses nowadays, we still have tanks. Why? Because people suffered in the past with intermittent water supply, not just 1 year, a number of years, and in a number of occasions. So Basically, the case of a roof tank is a case of the utility performing in such a way that it shows the customers that I'm here, I care for you, and I'm going to supply you with water every day. So, in my opinion, in countries where there are roof tanks, it will be difficult to get rid of them just because people don't feel secure in the short and medium term. There has to be many, many years that they go by, and the new houses, when they feel confident, the people, they will not install tanks. Now, energy saving, this particular method that we are proposing doesn't change the way the water is distributed. It's within the house. You may, if we still ration the water, tanks are needed because there is no continuous supply. You need to store it somewhere. And if you wish to simulate 24/7 in your own home, in other words, from the ground tank, you pump it to the roof tank, and then you have continuous water, then you will still need that extra energy to do this. The only way to avoid both is to have continuous supply at a reasonable pressure so that the customers feel confident that I'll do away with all my pumping equipment and my tanks and my storage. Sorry for taking.
Yeah, just explain maybe the question on the pressure, on the energy saving was, is related to the network. We are not pressuring the network by pumping. It's also will be, we are using gravity, so there is no change on energy consumptions. The other way actually, we are trying to relax the system from pressure, any additional pressure in the system. We're keeping at the minimum level. So it's not increasing energy, it should be saving. Quickly on the roof tanks also, this is after the meter, which is not related to the pilot. That's where we are introducing water demand management concepts. We have many other things to address. My colleague maybe in her actual presentation will address maybe some of this. And lately on the Jordan manufacturing, of course, the idea is to commercialize this. If we have proven the feasibility, and we think so, then we need to have a reduction in the cost of control valves. Good will be very attractive option if this can be manufactured in Jordan, of course.
Thank you. Can we all say thank you to the 6 presenters, Mahmoud, Dareen, Maha, Razan, Campos, Tamer. Thank you all. Thank you all.